Hi, my name is Hannah. I'm a Level 6 Forensic Science student, and my research project looked at the Tanimoto Similarity matrix for novel psychoactive substances through the decades, between 1950s and the 2010s. A novel psychoactive substance is defined as any substance which is capable of producing a psychoactive effect in a person who consumes it and is not an exempt substance. The aims of the research were to compare structures of novel psychoactive substances for similarities, track possible synthesis routes between the novel psychoactive substances, and to predict possible new psychoactive substances that could come on later in decades. To do this, the Tanimoto Similarity is used. The Tanimoto Similarity score is calculated using the following formula. C represents the number of atom pairs that two compounds have in similar. A and B are the number of atom pairs that are not common between either compound. The score always lies between 0 and 1. 1 meaning the compounds are exact same, 0 means there's no similarities between the two compounds. Finding the compounds was the first thing that needed to be done in this research. So sources such as the European Monitoring Centre for Drugs and Drug Addiction and the United Nations Office on Drugs and Crime were used to identify these compounds. These compounds were then compared in literature and then PubChem database to identify a unique reference number for each individual compound. The next step in the method was to calculate the Tanimoto Similarity score between the compounds. To do this, RStudio, an open source software, was used. It allowed me to do some programming to calculate all the similarities between the compounds. Once this was done, the data was imported to another software called Cytoscape, which then made the network. Networks have been used before to look at chemical similarity of drugs. Every compound is considered a node. The similarity score between two nodes is the edge. The higher the similarity score, the closer the two nodes are to each other. This is the network created by the compounds from the 1950s. There are three main groups in this network. The first is a small cluster of 4 compounds. It also contains a pair. The second pair is at the top right, and the last small cluster is at the bottom right. There are 3 compounds in this network that aren't close to any other compound. The average similarity of this network is 0.24. This is the network created by the compounds of the 1960s. The average similarity is 0.22. There is only one main group in the middle, and then this can be further broken down into 2 lone pairs and 1 lone compound. There is also a cluster at the far right. This is the network created by the compounds from the 1970s and has an average similarity of 0.19. There are 2 compounds that can push the opposite sides of the network away from everything else. The rest of the network is made up of 2 clusters, one at the top containing compounds from what is known as the 2C series and 2 other phenylamines, and the other group at the bottom of the network contains compounds that are mainly PCP derivatives. This is the network from the 1980s. It has an average similarity of 0.21. This network is formed a square shape. It has 1 compound in the centre, 1 pair at the bottom left. This pair is a development from the 2C series found in the 1970s. The top left has 3 synthetic cannabinoids, and the top right have fentanyl derivatives. There are 2 other compounds in this network, but they're not really close to anything. This is the network created by compounds from the 1990s, with an average similarity of 0.16. There are 3 main clusters. The first contains 5 compounds, the second contains 3, the third also contains 3. The final cluster here is another development of the 2C series. There are also 3 pairs. This is the network made from compounds in the 2000s and has an average similarity of 0.24. It has 1 compound on its own in the centre, 1 cluster to the left-hand side, 1 cluster at the bottom, and 1 cluster on the far right-hand side. 3 compounds in this cluster are a lot closer together than the last one in this cluster. This network is from the compounds in the 2010s and has an average similarity of 0.21. There is an inner ring in this network, surrounded by an outer ring. There is also another cluster on the far right of this network. There are also 3 other pairs in this network. This is a complex network containing all the compounds in this research. Their average similarity is 0.18. There is 2 compounds that have been pushed right out. These are PCE and GHB. There is 1 large cluster that is fairly central, which contains compounds from the 2010s, with 3 compounds from the 1990s and 1 from the 1960s. There are 7 small clusters in this network that contain compounds from the same decade. This suggests that compounds are clustering by decade. There are 9 pairs that have grouped together by decade supporting this. However, there is also 8 small clusters that contain compounds from a variety of decades. This contradicts the theory of clustering by decade. Therefore, an additional network was made where all compounds had at least 0.5 similarity. Creating this network helped reduce the amount of data and made it easier to look for patterns. To have an edge between 2 compounds, there is at least 50% similarity between them. There is a few small groups that are from a mix of decades. There is also one large cluster. This large cluster seems to be all connected to butylone in the centre. There is one small group on the top right, one small group on the bottom right, and 2 groups on the left-hand side connected by MMA. This network helped produce a pattern. The pattern found is as followed. It starts with a compound in an early decade. This compound is then found again later on, but has one difference, as new side chain. This compound is then found again later, but instead of a side chain there is a halide group. And then after the halide group, it is then found again later with a sulfur group. In this case, we have MMA to DOM to 2CB to 2CT2. The pattern was found again, this time starting with methcathinone. This then was found again with methadrone, which adds a methyl group to the benzene ring. This was then found again with 3-FMC with a halide group. The final compound in the series has not yet been found, but has been predicted to be found within the next decade. Using the PubChem database, this compound that has been predicted was searched for but has not yet been identified, but this is what I predict would be next. The pattern is then repeated again, starting with PV7. It then goes to MPHP, which adds a methyl group to the benzene ring. The next compound in the series is missing from my research. The final compound is alpha PVT, which has the sulfur group in it. The question mark in this series of the pattern could be one of 2 compounds. This one has a smaller side chain than the original compound in the series, but has been reported as use of a novel psychoactive substance in the early 2010s and would fit the pattern. The second possibility has the same side chain length as the original compound, but has not been yet reported as a novel psychoactive substance. This is my reference list for the presentation. Thank you for listening to my presentation. I welcome any questions at the following email address.